the AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.
Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Thank you, Anna, for introducing the session. A very good day to everyone, and thank you for joining. Welcome to AI for Good's AI and Machine Learning 5G webinar. My name is Jiaying Meng from ITU, the International Telecommunication Union. Today, we are excited to host another interesting talk titled Convergence of AI and Telecommunications Technologies. This webinar aims to overview the global trend in the convergence of AI and telecommunications technologies, to introduce the research activities at the University of Tokyo, and to discuss the importance of international standardization efforts and industry-academia collaborations in this new scientific field. As always, we are counting on you to help create an engaging discussion. If you have any questions, please type them on the video wall, and we will take them during the Q&A session right after the talk. Before officially kicking off the session, I would like to introduce our esteemed speaker, Akihiro Nakao-san, a professor and the head of Department of System Innovations, School of Engineering, and director of the Collaborative Research Institute for Next Generation Cyber Infrastructure at the University of Tokyo. And also my dear colleague Vishnu, who will be taking charge of the Q&A session. Without further ado, I would like to pass the baton to Nakao-sensei. Nakao-sensei, the floor is yours.
Thank you very much, Jain, for kind introduction. So let me put on my slides. Okay, hello everyone. I'm Aki Nakao at the University of Tokyo. Today, I'd like to talk about the convergence of AI and the telecommunications technologies. So the first, Jain already gave a kind of introduction about me, so I don't have to repeat, but I'm engaged in 5G and beyond 5G technology development, research and development. And also, I'm wearing several hats at the government of Japanese ministry. And also, I have a startup about local 5G technologies. So, but besides this bio, I have been engaged in a lot of activities in ITUT, and especially AI, ML, 5G challenge activities, and for the past 4 years. And we are running a local contest round, and from academia, we are trying to promote this activity because this is very important for our community. So I don't have to teach you how we develop mobile communication technology. We are running 5G as a commercial service right now, but we are aiming at the beyond 5G, which will be realized in the 2030s, expected. So, but now, global trends says that we are trying to integrate AI technology heavily in the next generation cyber infrastructure. So this is the picture of the Beyond 5G R&D direction published by Japanese government. And we are calling it Beyond 5G technology, but it's basically about the next generation 6G mobile technologies. And we like to further enhance the 5G's characteristics features. And at the same time, we would like to add new features that contribute to the creation of new values. So if you focus on the blue part, so we can extend 5G features such as ultra high speed, ultra high capacity, and ultra low latency and ultra massive connectivity. But besides that, we would like to add ultra security, ultra reliability, autonomy, and scalability, and ultra low power consumption. So all these 7 features are very important for the next generation cyber infrastructure. But now today's talk, we like to focus on this number 6, autonomy, so autonomous coordination among devices without manual intervention. So we'd like to borrow the power of machine learning and AI technologies. And now AI and telecommunication technologies are now converging together. So before I give the technical talks, I'd like to introduce our Beyond 5G Promotion Consortium. And we take international collaboration very seriously. So under general meeting, so we have a committee for planning and strategy, and also international committee. And I was in charge of the international committee and try to push a lot of international collaboration activities, such as O-RAN, Open RAN activity, and also LTN, high frequency band security, AI, and several other topics that need international collaborations. So today I'd like to announce the restructure of this 5G and 6G promotion forum. So we still have the 5G MF, which is 5G Mobile Communications Promotion Forum, 5G MF, and also a Beyond 5G Promotion Consortium, B5GPC. So we consolidated these 2 organizations into one in April 2024. And now we have XGMF, XG Mobile Promotion Forum. So the reason behind this consolidation is that we would like to promote deployment of 5G. At the same time, we like to develop the next generation technology for 6G. So we put a new name, XG. So this means that the 5 and 6G mobile promotion we have to do. So under this new organization, we also think that international collaboration is a very important topic. And among them, so we think that this AI and machine learning integration to telecommunication, that is also very important. So recently, so we are showing our visibility in several meetings, and this is like G7 Digital and Tech Ministers meeting held in Japan, and there we endorse the G7 vision of the future network in the beyond 5G and 6G era. So I don't have much time to cover the detail, but I can introduce G7 vision for future networks in the beyond 5G and 6G era. So the first one is end-to-end high capacity and ultra low latency. The second one, energy efficiency and environmental impact. Number 3, the multi-layered network. And number 4, frequency efficiency. And so in addition to these 4 elements, so we recognize that the openness, interoperability, and modularity are very important elements for future network. At the same time, our consortium had a MOU with various partners like Finland, a 6G flagship, Europe, 6GIA, United States, Next-G Alliance, and platforms for advanced wireless research. It's so-called POWER. And we utilize this framework of MOU to promote a specific collaboration with like-minded countries. And AI machine learning integration is one of the topics. So we recently held this Beyond 5G International Conference dated in February 1st and February 2nd. So if you are interested, so all these recorded videos are open now. So go to this URL and check out several videos. And I was chairing one of the panels. It was international collaboration topic. So I think you might be interested in that. We also have an international advisory board for Beyond 5G Promotion Consortium held in conjunction with the Beyond 5G International Conference 2024. There, we like to enhance the resilience of telecommunication infrastructure. So lots of countries, like-minded countries, think that this is a very important topic. So I can just flip several slides from now. So we take this international collaboration very seriously, and we took opportunities to discuss with all these partners and give talks and have panel discussions and all that. And we think that the several important topics are identified. One of them is Open RAN. So the Open RAN, what is Open RAN is, so this is like defining open interface between the various RAN element, the radio access network elements, so that we can develop flexible and scalable radio access networks. And also we like to expand opportunities for new vendors to enter the base station market, which will revitalize the market. And we also like to allow vendors to focus on developing devices that they are very good at manufacturing. So, and this O-RAN activity, well, O-RAN is one concrete organization alliance along with in alignment with this Open RAN activity. So they define O-RAN architecture, and now the O-RAN Alliance is a worldwide community of more than 300 mobile operators, vendors, and research academic institutions. And if you notice this, among these logos, our lab is one of the members. And we like to promote research using the O-RAN architecture. So especially, academic institutions are interested in this RAN intelligent controller of the O-RAN architecture. So there, we can take advantage of AI and machine learning in the architecture. And this is sort of like a SDN, a software-defined network architecture. So there is a controller that takes advantage of machine learning and tell all the radio access network component like CU and DU and RU so that they can utilize the power of the AI. So we discussed the use cases among these alliance and the traffic steering, power management, the resilience, and recently we noticed that dynamic spectrum sharing using the AI is a promising set of applications. So we can manage the radio resources and application traffic provisioning, and also UE, so we can predict UE behavior so that you can control the resources based on the UE behaviors. And the resilience is a very important one: anomaly detection, disruption prediction, and the congestion mitigation. So in US, dynamic spectrum sharing is a very large topic which catches people's attention because we have a limited amount of resources in the frequency domain. So we like to efficiently use this spectrum. So we can use AI to dynamically and efficiently sharing the spectrum. So just to advertise our activity, so we plan on O-RAN Alliance Global Plugfest Spring 2024, initiated with focus on 6 topics. So this is scheduled in various places, and our lab is hosting this also Plugfest in this spring. And all these 6 topics are as follows. And we are especially focusing on energy consumption enabled by RIC, the RAN intelligent controller. So with power of AI, we like to reduce the power consumption and also efficiently use the power resources. So all the other topics are held by the other institutions. Japan OTEC is one of them. And I don't have time to name all these places where Plugfest are held. But if you are interested, you can go to this website and then take a look at this activity. So from now on, so I'd like to talk about the global trends of the convergence of AI and telecommunications business. So I attended the Mobile World Congress. I think many people have attended this large international exhibition of cutting-edge technologies in the mobile communications. So there are 2,700 exhibitors, over 100,000 attendees from over 200 countries. But there we noticed that there are lots of exhibitions that symbolize the convergence of telecommunications and AI. So for example, the AI-RAN Alliance was announced by NVIDIA. And from Japan, SoftBank is a founding member. And also there's an AI LLM led by SK Telecom Korea. Well, there are several activities introduced in Open RAN, O-RAN trend. So for example, the OREX SRI was established by NTT DOCOMO and NEC. So we noticed that there are lots of AI-enabled telecommunications technologies. So one of them is application of AI to telecommunications and fault prediction and fault detection and advanced signal processing. And we have to do a highly parallel processing, but with power of AI, we can do more. And also inter-cell coordination like DMIMO, distributed MIMO. And next one is a very interesting one by Nokia. So the AI native AI interface. So instead of doing legacy, transmitter and receiver technology, we replaced all these encoding and decoding part into with the deep learning, deep DX and the deep RX. So according to Peter Vetter's talk at Nokia, so they can enhance the throughput by 30% by means of AI technologies. So it's called AI native AI interface. Also, there is an interesting work done by the same group, the fusion of communication and sensing, because if we can predict we can sense the UE behavior, so then you can control the signal. So if you combine the communication and sensing, the joint communication and sensing GCAS, so we can do a better job at using the power efficiently. Also, at MWC, we noticed that the low power consumption is the great interesting topic for telecommunication companies. So there are technologies to flexibly turn on and off base station functions according to communication volume. And we can do micro saving with a time division multiplexing. For example, if you don't have a resource blocks used for communication, so then you can turn off for a short time. If we can do that, for example, if you turn off the power amp so that you can significantly save the power. So it's called a micro sleep. Also further, we can do reallocation of radio communication resource blocks, and then you can turn off, actively this at a specific timings. It's called a deep sleep. So all these technologies combined with AI, we can do a better job. So this is not the whole list of examples of AI-enabled telecommunications technologies, but now it's tracking the movements towards this AI-enabled telecommunications. All the players, all the stakeholders are moving in this direction. So, so here an example, another example of AI-enabled telecommunications makes sense. So telecommunication technology must evolve taking advantage of AI, especially AI at edges. So all the telecommunication companies think that we have to make a ongoing investment in RAN, sustainable, because we have to make a case here. If you want to make a telecommunication business sustainable, we can, for example, have the Edge AI cloud just beside this telecommunication, mobile networking. So Edge AI computing is particularly important because we can leverage Edge AI for both RAN evolution and the low latency AI interface inference from collected data. So for example, if you take a look at this figure, so traditional 5G networks, we have a long delay to get to the cloud data center where you can use AI. So of course, you can create the cloud very close to the mobile networking. So then you can utilize the Edge AI cloud at a shorter distance, and that means that the low latency. So for traditional 5G networks, even though we can reduce the latency by 5G technologies, it doesn't make sense if you have a long haul delay between a mobile networking and a cloud. But if you can place this Edge AI cloud close to the base station, so then it makes sense to shorten the distance, shorten the latency of the 5G or maybe 6G technologies. So Edge AI cloud can be used for improvement of RAN because we looked at the example of AI, native AI interface and inter-cell coordination. So it makes sense to have the Edge AI cloud to improve the RAN. At the same time, we can use low latency AI inference. We take the data and process that in the Edge AI cloud and get the feedback to all these actuators at a very short delay. So all of these trends, so people think that it makes sense to have Edge AI cloud close to the mobile network. So that's why I think that now the AI and telecommunication technologies are start getting the conversion. So let's see the one interesting movement. It's called the AI RAN Alliance. And we, UTokyo, plan to become a member of AI RAN Alliance soon. But, when I made this slide, so it was a couple of weeks ago, but now, so we are a member. And so we actually are one of the founding members. So the reason why we are a member is that they expect that academic partners are to be in the loop For example, Northeastern University is one of the founding members, and we are the second, first in Japan, but second in global environment. So, all these others are industry partners, but they think that academic institutions are very important partners to push this AI integrated telecommunication technologies. So I think one of the very important application of AI integrated telecommunication technology is secure and open and resilient by design. So this message was published by White House in the United States. So all these countries sign up for the principle for 6G. So they endorsed by joint statement, and we like to develop this secure and open and resilient, and especially resilient and reliable, secure connectivities is very important. And I think this AI can be used for achieving these goals. So from now on, I like to give a little bit technical contents for students and our colleagues, researchers. So one of the things that we are looking at is to achieve the resilient and robust infrastructure is that AI-enabled robust and resilient 5G system. So we use few-shot learning and deep reinforcement learning-based resource allocation in the 5G system. So those who are not familiar with the few-shot learning is that we can use a very few amount of data and still achieve the very good result. So we have prediction of intelligent traffic flow prediction. It produces better result than LLCM and few-shot learning. The power, if we look at the error, the cumulative quadratic error, according to the number of flows, you can significantly reduce error of the prediction of the traffic. So that even though the traffic pattern is like this very complex shape, but we can predict the traffic pattern nicely with the few-shot learning. So this few-shot learning, the idea is coming from the image processing, but we can apply that to the traffic prediction. So another thing is now, it may sound mundane, but we apply the deep reinforcement learning-based resource allocation of NFs. We can significantly reduce the cost of the resource allocation. Oh, by the way, I don't have much time today to go into the detail, but if you are interested, we are presenting this, result in ICC 2024. I think this is in June. So, if you are interested, you can check it out there, our paper. So another example that my student is working on is that AI-enabled network slicing for optimization of application QoS. So we talk about network slicing for long, but if we can dynamically and autonomously create a slice per application characteristics in real time, so this would be good. So we collected 60 UE traffic for 1 month, and that includes that over 290 applications traffic. So then we can train the machine learning model so that we can predict from the, this is not DPI, from the surface of the traffic, like the time series of packet length or some header information, and we are not allowed to take a look at the content because of the privacy infringement. But just from the surface information, we can predict over 90% of the accuracy. But in order to do that, we have to buffer some traffic for a short amount of time. Like, up to 100 milliseconds, we can achieve like a very high accuracy number, and depending on the traffic. But interestingly, some application traffic we train, we use more data and train the machine a little bit longer. So then the accuracy degrades quickly. So we have to know the data characteristics more closely to get the good result. So this is still ongoing work, but next week, my student is going to present this result in Korea, notes and net workshop. So if you're interested, you can check it out. So another thing is robust and resilient 5G system. And we haven't applied the AI and the machine learning technique yet, but this is very interesting work. So let me introduce this work also. So in Japan, we have lots of disruption in the mobile network these days. And one of them is, the reason is that we have a large number of devices connected to the 5G network. So our design of the core is not yet ready for a large number of connectivities. So, and we take a look at the problem, and we found that the C plane is congested. So C plane, control plane is congested, meaning that, so after device is connected, we can use network slicing idea to isolate traffic per application. But congestion is happening in attachment of the device to the mobile network. So there you have to take a closer look. And before UE getting attached to MF, so we have to do a prioritization. So this is called C-plane slicing. And if we can apply this technique, so then we can achieve like 3 times more devices can be connected. So this is still a simulation, but this is interesting result. And we like to add a prediction of the UE behavior in this work using AI. So this work is done by a master student, and we publish this. And if you're interested, you can read this paper. So we can go on like this, but there are many examples that my lab is doing, AI integration into telecommunication services and infrastructures. So recently we got funded the Aspire project, which is the very big project for international collaborations. And there, so we are heavily using AI, and we'd like to achieve the inclusive creation of next generation cyber infrastructure using local 6G. So because we can modify the infrastructure of the local network, so we are calling it the local 6G. So there, the goal is to establish fundamental technologies for next generation cyber infrastructure, even more robust as a social infrastructure. So, but there, so we have a partner with Finland, and Finland 6G flagship project. We like to do an international collaboration, but not just the Finland, but we like to extend the loop to different countries. So I can just briefly introduce what we do in this project, and we like to do, just the you can focus on the highlighted part. We like to do a fault-tolerant wired wireless infrastructure with AI, O-RAN RIC or AI-RAN, and dynamic frequency sharing with AI, O-RAN RIC and AI-RAN. So other things are robust MMTC, LEO, NTN technologies, and advanced security utilizing local 6G base stations and all that. But the top 2 topics here are AI integration to the telecommunication. So not just the industry stakeholders, but also academia is very much interested in this AI integration to the telecommunication infrastructure. So here's a PI list. Me, myself, and Professor Matti Latva-Aho. So he's also a global fellow at the University of Tokyo, and he's a leader or the director of the 6G flagship project. So we all think that this movement is very important. I became a guest professor, the first guest professor at University of Oulu. So we start with Finland and we like to extend the loop to different countries. So here is the list of the partners of this project. So that spans many countries and many regions. Even Africa is a part of this loop. So, and we share this view and in various venues of the academic events, NGCI Symposium and also 6G Symposium. And there we discuss this matter intensely. So just briefly, so introduce, we think that, we are developing a new radio technologies, but legacy protocol on top of new radio, like, TCP transport protocol must evolve according to the evolution of the new radio. Because, for example, this is a Starlink LEO throughput change. So maybe many people think that Starlink communication is very stable, but it's not actually. So my bachelor student found out that every 15 seconds, so the throughput changes very heavily. So TCP protocol on top of this new radio technology is deceived by this rapid fluctuation of the throughput as congestion and slow down the TCP throughput. So we like to improve the TCP protocol on top of this fluctuating new radio technologies. And my student already designed this new TCP congestion control. And there we use machine learning and AI to predict the throughput on the next time slot. And then accordingly, we adjust the behavior of the TCP congestion control. And we conclude that up to 25% of throughput improvement if we deploy this new congestion control over Starlink LEO network. So this is another example that we like to explore in this Aspire project. So finally, because this is AI ML 5G challenge related event, so I think this topic was covered by my previous presentation, maybe 1 or 2 years ago, but I like to repeat this part briefly because this is very important. So ITUT is running this AI ML and 5G challenge for 4 years now. And so we have been participating in this contest and let my students work on this contest. So there are 3 themes in the first year, and KDDI contributed a problem statement, and the contest topic is analysis of the route information failure in IP core network by NFV-based test environment. So my student participated in this event, and I'd like to introduce a success storyline of my students, what he did in participating in ITU 5G AI ML challenge. So he participated with his colleague students. 4 of them participated in a contest, and they won the global round and got awarded. But they didn't stop there. So if you participate in this event, so even if you get awarded, don't stop here. So what they did is that they submitted the result in IT journals and also in other publications. And they extended their research and publish more and put the results in practice. So I can briefly, introduce what happened. So, these are 4 students participating in the ITU AI ML and 5G challenge. and they got the bronze championship, third prize. So, and they are invited to publish a paper, and the result has been published in ITU journal. So it was, published in 2021, and it was received well, but they didn't stop there. So they extended, under my supervision, they extended this work and added more AI element in it. So I can briefly introduce, due to the time constraint, I can briefly talk about it, but if you are interested, you can read this paper. So what they did is that because, this is the contest for proposing the machine learning model for predicting the network failure. But the network failure event is not much. So there are not many supervising data to predict the failures because they're not actually, the large number of instances in the real network. So somehow they would like to generate the supervising data and improve the performance of the fault detection. So they use GAN to generate the create data realistic enough to help us improve the accuracy of the results. So they try to generate the supervised data for network operations by GAN, CGAN, and WCGAN. So they tried many GAN technique. GAN is, if you're not familiar with the GAN, maybe you can study GAN. But they can generate data and try to enhance the data set for supervising the machine learning model. But the result is very interesting. So this is the original data, the blue one, and this is GAN enhanced data. So we can successfully increase the amount of data, but the result is counterintuitive. So there is no obvious change in accuracy. So even though we can increase the number of supervising data, we're not getting a good result. But my students went ahead and tried the following things. So they can improve the fault prediction accuracy by balancing unbalanced teaching data, supervising data with the GAN data generation. So instead of increasing the individual type of the data, so they try to balance the unbalanced data by adding more data to balance out with the other data. So then they can increase the overall accuracy by 5%. So this example is just a storyline, success storyline for my students, but this could happen to you. This could happen to everyone. So I'd like to encourage participating in a contest run by ITT. And also, even if you win this global round and get awarded, nice award, they prepare, but please don't stop there and submit journals and other publications and enhance the result. So then glory is coming to you. Okay, this is my final slide today. So we observe global trends of utilizing AI and ML technology into RAN, and not just RAN, but overall telecommunication technologies. And research communities should play an important role here to explore the research space for this one. So we have been doing that for several years now, but we have to do this in the next coming years. And now industries are seriously putting efforts into AI integrated telecommunication technologies, and examples are many. So today I introduce AI RAN Alliance, O-RAN RIC activities. And today I don't have time to talk about ION, innovative optical wireless networking global forum created by NTT Japan. but it's a global forum. Everyone can join this forum. And there, AI is taken seriously for improving entire optical network and wireless network. So academia and the industries must collaboratively accelerate the research and development on AI-integrated telecommunication technologies. And we would like to enable more and more technologies along this line. And hopefully I can report back here for the next web seminar with lots of results. Thank you very much for your attention. This is the end of my talk. I'm happy to discuss with you. Thank you very much.
Thank you, Nakao-sensei. That's a very nice summary and great pointers for both researchers and the students as well as the industry. Thank you very much. And I also personally thank you for the collaboration with Rising as well as the community there with your leadership. Thank you very much for the AI/ML 5G challenge partnership and collaboration that we have been having for many years. Now, a question from my side. Let's look at AI, different type of models. I think in your talk you mentioned deep reinforcement learning type models and some use cases related to that. Also, you mentioned AI native. So that's very interesting. I want to ask you the different types of models, AI models, which will be used in beyond 5G and 6G type of networks, especially given the trend towards natively integrating AI. If you remember in ITU, we had this work on different type of overlays, AI machine learning type overlays. But now the trend is more towards integrating AI natively in the networks. So I want to ask you, in the use cases towards 6G, the usage scenarios which are mentioned in 6G, what are the type of models which will be used? Would the deep reinforcement learning and such type of models that we discussed, would they still be there? Or the native integration, what kind of changes would that bring to the type of models which we will apply in future networks, please?
Okay. Thank you always for good and hard questions, Vishnu. So, so my answer would be that because AI needs a complex processing, right? So, for example, so when Peter Vetter presented this AI native AI interface, I asked the question. So we needed to reduce power consumption, but if you use the complex AI processing in RAN, so even though we can gain a 30% of performance increase, so we may not be efficient in terms of power consumption. So there is always a balance between the performance gain and also power consumption when it comes to AI. So whenever a simple algorithm we can use, so we should be doing that. But for this type of application like AI native AI interface, deep learning method may be necessary. So in this case, so we may want to borrow the power of the semiconductor business. So semiconductor specific to do this AI processing chip. So then we can justify the use of AI by, because power consumption is less and less if you make, if you spend money to make semiconductor chips to do that. So I think my answer would be that we have to think about, the investment and also end result in various aspects like power consumption, cost, and all these put in the equation, and you have to choose the AI machine learning model so that it can make sense for particular use cases. So there are, in 6G, there are various technologies that we like to borrow the power of AI. But each one of them, we have to think that, okay, so in order to reduce power, at the same time, we can use the power of complex processing AI. So what would be the equations like, and we can optimize this equation. So this is what it would be necessary in AI integrated telecommunication technologies.
Great. Yeah. Thank you very much. Thank you very much. You mentioned open RAN architectures.
Yes.
I want to ask about the role of such architectures in 6G or beyond 5G architectures. Are these kind of open RAN architectures flexible to develop new type of usage scenarios, usage applications on top of 6G to satisfy the new requirements which are mentioned in you? Are these kind of architectures good, flexible to develop applications to satisfy the new requirements, please?
I see. So in fact, O-RAN RIC is for 5G network still. But so this a new way of using AI for RAN, the radio access network, is pretty new, and it's not yet mature in the 5G network yet. So I would say you are right in the sense that towards 6G, we have to develop, enhance this feature for the complex problem like traffic steering, power management, resilience, and even the dynamic spectrum sharing that I listed here. So we think that for 6G, we have to think all these problems, but there is no good way to solve this without complex, computational processing. So for that, some part we can use AI, but there is the framework called RIC, Run Intelligent Controller, to put AI or machine learning into place of RAN architecture. So this O-RAN RIC is just a framework, and then individual, the non-real-time and the near real-time RIC applications here. So if you put pieces of the implementation into this architecture, so many people can utilize the same application into their framework, into their O-RAN RIC compliant equipment. So this is the idea. So O-RAN RIC doesn't provide the individual, concrete AI functions or machine learning. It's just a framework. But once you develop applications utilizing AI, so then you can deploy this in O-RAN RIC compliant devices and equipment.
Very good. Yeah, thank you very much. That clarifies that. I want to ask you maybe one last question. Just stepping back, I remember your significant work in IMT 2020. I remember your papers and publications both in ITU as well as outside. We had focus group IMT 2020, and you were leading a significant amount of work. So now it is almost 10 years later. We are talking about IMT 2030 now. So
Yes.
yeah. So I want to ask you, the pre-standard research work that you did in with great leadership you did in IMT 2020 versus against what is happening in IMT 2030. What are the directions that your guidance, please, your guidance on the type of pre-standard research which we should do in ITU as well as outside, please.
Okay, thank you very much. Now, I remember the days that, when I was working in IMT 2020. At that time, I was leading a softwareization working group, especially, and we worked on the softwareized architecture, including network slicing. So at that time, the softwareization is the big movement I foresee, and so I truly believed in that softwareized, flexible infrastructure is coming. And now looking back, so networks slicing is standardized both in ITU and also through GPP. And I was right in the sense that this prediction was correct, but of course, my prediction and our prediction done together at ITU are backed up by industry development. And so right now, so the same thing would be happening here. So we think from academia that AI ML integration to a telecommunication technology is very important, but it still has a research aspect in it. For example, the technical stuff that I presented today, so it takes time to be deployed, or it's still premature to be put in practice into the real telecommunication arena. But when we talk about a pre-standardization activity, so this is very important thing, and also academia should play an important role in a pre-standardization arena, because we truly think that this is happening, this is coming, and we can use this power of AI and machine learning technologies. And so we see that lots of interesting examples and also opportunities. And then we talk to industry people, and using this alliance and also forum and maybe a focus group at ITU, we can co-develop things with the industry partners. But at the end of the day, so industries are very important in pushing the standardization. So we can just, we crazy researchers think that, okay, this is the direction that we should go. And so this may be right, this may not be right, but academia and the industry collaboration is success, the key to the success in this. So I think for IMT 2030, there are many important topics, but AI ML is one of them. So I like to say that, okay, so this would be the very important topic to work on, collaborate on among academia and the industries.
Thank you very much, Nakao-sensei. Thank you for patiently answering all questions. Jane, back to you. Thank you.
Thank you so much, Vishnu, for the Q&A session, and thank you, Nakao-san, for your presentation. I saw questions from our audiences, yet due to the time constraint, we're not able to host it online live. Yet, we encourage you to stay until the end of this webinar and discuss all of these questions with our guest speaker through a neural network platform. So at this point, I would like to thank everyone for sparing your valuable time to join the session today. And again, let me express my gratitude to our speaker, Nakao-sensei, for his contribution. We have more sessions in the future, so please check the AI for Good platform program page for details. You can also interact with us and other participants on the Challenge Slack channel. We look forward to your future participation. Thank you for joining, and have a nice day.
Thank you very much.
Thank you for participating in today's AI for Good session. We hope you've learned something new innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good.
The AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.